Hello everyone, this is Emmanuel from airtrain.ai. A quick word before we get started. We just released this week a demo video for our free batch evaluation tool for LLMs. So check it out in the link in the description below and sign up at airtrain.ai to get access to the private beta. Today, I want to talk about a novel way to evaluate and grade large language models. When models get published by the community, they always come with metrics and benchmark results, and that's very helpful to rank models, but it doesn't tell you how a model performed on a specific task or a specific dataset. Researchers came up with the idea of using other LLMs to score an LLM. You can think of it as one model is the student taking a test, and the other model is the teacher grading the test. In this video, we'll go over some baseline concepts and then we'll review some literature around this topic to see how that works. First, let's talk about model evaluation. Model evaluation is arguably one of the most important parts of the model development lifecycle. Here's how it works. When preparing a training dataset, we hold out a small part of it, typically 10-20%. We remove it from the training dataset so that the model does not see that data during training. This dataset is called the evaluation or eval dataset. After training, we use the trained model to generate inferences on the eval dataset and compare those with the ground truth, which is the labels that are present in the eval dataset. In traditional machine learning models such as regressions, classifiers, or computer vision, there are some well-established metrics to measure model performance on an eval dataset. In natural language processing, things are a little bit more tricky because the output is unstructured. It's just natural language. So many different responses could be correct. For an overview of available metrics and benchmarks for LLMs, I encourage you to check out my video for my talk at the AI Engineer Summit. I left the link in the description below. The problem with usual metrics and benchmarks is that they only evaluate for specific tasks such as summarization, or translation, or high school math, and so on. But if you're trying to evaluate something very specific, for example, creativity, or politeness, or relevance, there's no existing metrics. There is a fairly novel way to do this, though, and that is to use a scoring model to evaluate for specific attributes. So let's take a look at 3 academic papers that attempt to do just that. First, let's take a look at a paper called LLM-Eval published by Lin et al. From the National Taiwan University in May 2023. They use a single prompt method to get a scoring model to grade a dialogue along 4 dimensions: appropriateness, content, grammar, relevance. Unfortunately, the paper doesn't really say what appropriateness or content or relevance mean. The prompt looks like this. First, they describe the required output schema for the metrics. Then they lay out context and dialogue response to score. Then the model returns the scores. They evaluate how good the scores are by measuring how much they correlate with human ratings using Spearman correlation coefficients, which is a percentage. 100% means that the scores are fully correlated with human scores, and 0% means that the scores are not correlated at all with human scores. Then they compare those coefficients with established metrics to see which correlates best with human results. Now, looking at results in this table, we have 5 datasets being evaluated. The top rows here correspond to a number of metrics-based evaluation techniques. Then APP is for appropriateness, CON is for context, GRA is for grammar, and REL is for relevance. The bold number is the highest Spearman score for each column, and the last column is the average. So as you can see, LLM-Eval, without human references and with a grading scale going from 0 to 5, beats all other methods. As scoring model, they tested Cloud from Anthropic and the GPT models from OpenAI, and Cloud seems to perform better. The key insight here is that top-shelf LLMs like GPT-4 and Claude correlate better with human score than metric-based eval methods. Next, I want to look at a paper called JudgeLM, published by Zhu et al. From the Beijing Academy of AI last month in October 2023. They created a dataset of 105,000 examples, each containing a question, a pair of answers generated by various LLMs, and a score given by GPT-4 to judge which is the best answers of the 2 in the pair. In this context, GPT-4 is the teacher judge, and its ratings are used as ground truth. Then they fine-tune a set of models from 7 billion to 33 billion parameters on this judgment dataset and test how the models agree with GPT-4 on the eval dataset, which is 5,000 examples. You can see the results in this table. You can see that the fine-tuned model, JudgeLM 33B, agrees with GPT-4 89% of the time, which beats GPT 3.5. The main insight here is that a relatively smaller model can be fine-tuned to be reliable judges of other models, provided a high-quality training dataset is available. Finally, let's take a look at a paper called Prometheus, published by Kim et al. In October 2023. They created a dataset called feedback collection. This is how the dataset looks like. It contains an instruction part where the model being scored is being asked to carry out a task. Then a rubric is laid out to explain to the scoring model what each score value looks like from 1 to 5. What is a 1 score, what is a 2 score, and so on. Then it contains the response to evaluate and a human-curated reference answer to show the scoring model what a good answer looks like. The dataset has a total of 100,000 entries with 1,000 different score rubrics and 20,000 different sets of instructions and reference answers. So they use that to fine-tune Llama 2 13B on this dataset and evaluate on a holdout dataset how Prometheus scores correlate with humans. Here we see the results. On the x-axis, we see various eval datasets. On the y-axis, we see different scoring models. And the color indicates how well scores correlate with human scores. As you can see, Prometheus correlates with human scores better than GPT models. The key insight here is that a scoring rubric and a reference answer vastly improve correlation with human scores. This looks like a great method to evaluate LLMs on arbitrary dimensions. So what are the potential issues with these AI scoring techniques? Well, the first potential issue is bias. It's been shown that when multiple choices are possible, models will have a bias towards the first item in a list. If you have a multiple choice question, then the model will have a bias towards the first answer on the list. Also, it's been shown that models will have a bias towards themselves. If you use GPT-4 to pick the best answer out of a set of answers generated by different models, GPT-4 will have a bias towards the answer that it has generated itself. So secondly, variance is another issue. Models are inherently stochastic in nature, which means that their outputs are non-deterministic. With the same input, you can prompt the model multiple times and it will have different answers. And it's been shown that changing punctuation or spacing can yield different results. So it means that varying your scoring prompt may yield different scores from the same input. So that's a variance problem. A third potential issue is contamination. If your eval dataset was part of the pre-training set for your scoring model, it may already have seen the eval data and therefore have some inherent bias. At the top of this video, we asked whether an LLM can score and evaluate other LLMs. We reviewed 3 pieces of academic evidence that seems to point out that this is indeed possible and opens a wide range of arbitrary scoring dimension. We learned that without fine-tuning, the best-in-class models like Claude and GPT-4 are still the best evaluators out there. It is possible to reach similar performance with smaller model, but they need to be fine-tuned on high-quality datasets. And finally, we learned that adding a reference answer and a scoring rubric goes a long way to make scores correlate better with human scores. We also looked at the possible biases, like bias for themselves, or positional bias, or contamination, and so on. Now, bear in mind that these articles are only a few months old and that this is a quickly developing field. At airtrain.ai, we have our own scoring model that can evaluate models for arbitrary properties on your own dataset. It's free and easy. Upload your dataset, select models you want to compare, and specify your scoring properties in natural language, and our scoring model will produce dataset-wide distributions of your scores. Sign up at airtrain.ai for early access.